So in this video, we're going to talk about operators in RxJS. So we've already seen a couple operators. Interval is one of them. In previous videos that I'll link up here in a card, we saw other operators such as combine latest and merge, which are also a type of creation operator. Specifically, they're combination creation operators because they combined two other streams and created a new stream. Whereas interval is a creation operator. It doesn't take in any observable. It just takes in a number and returns an observable. So those are creation operators. But what we also have in RxJS are what are called pipeable operators. So it's a weird name, but think of them as non-creation operators. They're operators that act on a stream that you already have. So when you have a stream, let's imagine it's like a flow of water, right? Like a literal stream that would go through a pipe, like plumbing. And that's exactly what pipeable operators are. They can be composed together to form a pipeline your data flows through. So here we have this observable that just emits these values every second. And if I go ahead and run this here, we can see that it works and it just counts from 0 and increments by 1 every second and just goes forever. But let's say I only want even numbers. So what you can actually do is before subscribing, you can call pipe. And what this lets you do is put some operators here. So I'm going to go ahead and use an operator called filter, which if you're familiar with arrays in JavaScript, it's pretty self-explanatory. So that comes in from RxJS/operators. And with filter, it takes a callback function just like the array, where I get some value. We'll just say I, and we're going to just check if I divided by 2 has a remainder of 0. So I mod 2 equals 0. And if we go ahead and run this, you can see it's only outputting the even numbers. So why is it necessary to put this pipe? Well, it technically is not. You could just as well take this filter, and what this is it's a higher order function. It's a function that when called returns a function. And that inner function, the function returned from the function, that inner function is a function that takes as its argument a source observable and returns an output observable. So that's maybe a little bit confusing. So let's explain this again a little bit differently. So what the filter operator here is doing is it's returning a function. So now I have a function here, and that function can take in a source stream, and I get an output stream, right? So it's a little bit nicer to use the pipe notation than to do it this way. So we could do it this way though, and then we could say output stream, and TypeScript complains. So before it was inferring that that was a number because it was in the pipe. Now it does not know that because it's not in the pipe. And I'll go ahead and remove that pipe that's doing nothing. So we can see it does the exact same thing as before. So you could just use regular functions and you know, use like your Lodash throttle and debounds and things like that manipulate time. But RxJS is a lot nicer. It allows you to have these fluent dotless or point-free pipelines. And by point-free, I mean you don't have to do like dot filter, dot map, and so forth, which is a functional programming thing I won't get into in this video. So anyways, rather than doing this syntax, you would normally just do dot pipe, and then you'd put your operators in there. And let's say after filtering it, you want to double the numbers. You could use map, which takes a value and maps it to a new number. So I'll go ahead and import that. And so you can see we just separate the operator calls by commas here and list them out. And we could do this any number of times. So if we wanted a whole long pipeline, we could do that. So I'll go ahead and run this. So it's going to get the even numbers and double them. So it should be like 0, 4. There we go. So the reason, again, you use this pipe is when you have multiple operators and the syntax starts to get all gnarly. So if we look here at this example, these are both the same exact thing. We have an observable, and we call pipe and give it a pipeline of operators. And what happens is these operators get so-called lifted into the stream. So under the hood, RxJS is doing this lifting. So technically, the observable has a lift method on it, and under the hood, it's doing observable dot lift, and then a function where that function is whatever this operator returns. And so you could say the observable is actually lifted into the pipeline. So up here we have the pipeline as it's created under the hood, and this observable is lifted into that pipeline. So you have some stream going over time, and that is lifted into a pipeline. So let's just say your pipeline is sitting above it, for example, and we are lifting the stream up such that it flows through a pipeline that transforms, filters, modifies time, does all sorts of things. Later we'll learn about higher order observables where you can have like a branch of logic going off, like maybe like two things that are like racing, and like you take like whichever one finishes first, or you might have like a bunch of network requests and you want to make sure that like 1, 2, and 3 come back in order, and so that you get out the other end like 1, 2, and 3, or maybe you don't care about the order and you're fine with like whatever order they finish in, or maybe you only want this one to start when the previous one is done, and so forth for the next one to start when the previous one is done. So you can have really complex logic expressed very succinctly and declaratively as a pipeline, and your observable gets lifted into that pipeline, and on the other end, this consumer, all it has to know how to do is call .subscribe. It does not need to be concerned with whatever is happening in here. It does not need to be aware of that. So that is how to conceptualize an RxJS pipeline. If the higher order observable example confuses you, just ignore that for now. I'm going to have another video exclusively dedicated to higher order observables in this playlist. So make sure you subscribe and like, so it gives me encouragement to create that. And for now, just pretend we have like our map and our filter, or these could be in whatever order, or you could even have another map over here such that you are only applying this mapping if the value actually passed through this filter. So these values come through left to right, like you have a value coming through, and then it reaches this pipeline, and map goes, oh, I have here a circle, and you're mapping that to a square or a triangle or whatever it is. It's changing the value, and then it takes that new value and it keeps flowing down the stream, and the filter gets the square, and it inspects the square and looks at it, and it goes, oh, I'm looking for triangles, and that is definitely not a triangle. So then the value does not proceed further down the stream. Or maybe it was looking for triangles and it goes, oh, that's the right value. It's going to proceed down the stream, and then this map transforms it again, and maybe it turns it into 2 triangles or a diamond or some other shape. So I'm using shapes here just as an abstract example. Really, you're going to be dealing with values like objects in your program, or numbers, or strings, or key press events, or some stream of something like UI events or data. So anyways, that's the pipeline. So imagine you have your stream flowing over time from left to right. That's time, and that's where it completes. And you have some values on here, like a 1, a 2, a 3, a 4, and this is what our interval creation operator created. It created a new stream for us. And then we called pipe, and we used our filter call, and we put our filter, and this gets lifted into this stream. And what that means is it sits in the middle of this and receives all the values that are coming through. So if we had map after this, so in this case, this filter takes this stream in as an input, and then it returns a new stream that only has, in this case, 2 and 4. And then our map takes in this source stream and returns a new output stream where the numbers are doubled, so it's like 4, 8. The other reason you want to use this pipeline versus creating your pipeline like this is pretty obvious here from this example. This one here is really hard to parse. I've turned on color-coded, I've turned on an extension in my editor that color codes the parentheses here, and it's still very hard to follow. I do not like this example at all. So the idiomatic way to use RxJS is with the pipe method and passing in your pipeline of operators like this. And so I've introduced you to a couple of operators like filter and map, which change the values and omit values. We can also have operators that deal with time. So another operator is delay. And if we delay by 5,000 milliseconds here and run this, we will see that there is quite a delay on receiving these values. But once we do start receiving them, they come at a normal pace. Each one is delayed by 5 seconds, so the relative difference between them remains unchanged. So we'll get more into these operators later, but let's go ahead and learn how to learn about an operator. So this is the RxJS docs, and you can see under the operators section, they have creation operators, and we've already learned a few of these, like interval. Actually, interval was the only one out of the actual creation operators, but then we had the join creation operators, and we saw combine, latest, and merge in the previous video. Again, I'll link that up here. And there's a whole bunch of them, and I'll try to go through this whole list later. But you can see under filtering operators, we used filter. Under transformation operators, we use map, which transform the values. And if we search for delay, we can see there's a utility operator, delays the emission of items from the source observable, which was the concept we just learned about when I was discussing the operators, how the operator takes in a source observable and returns an output observable. So it delays the emission of items, which was each of the events on the stream that I drew out, and it delays them by a given timeout or until a given date. So if you just pass in a number for a delay here, the delay duration in milliseconds will be applied, and each of the values emitted on the source stream will be delayed by that amount of time. And you can see it returns an observable that delays the emissions of the source observable by the specified timeout. And you can see here from the marble diagram, which we learned about in the previous video, I'll link here in a card, that the source observable is transformed into the output observable by the delay operator. And because it's a pipeable operator, you have to already have a source stream or source observable to operate on. And then you have to call pipe on it or use the ugly syntax. Hopefully you use pipe. Hopefully I've convinced you that that's the right way to go. So When you start first getting into RxJS, these docs can be a little tricky to read because it's like delay the source observable, and later we'll get into nested observables, and it's like the inner observable and the outer observable and the observer, and it can really make your head spin. But I'm going to try to explain this in a simple way, and I'm going to try to create the videos I wish I had when I was learning this. So that's how operators work. In the next video, we'll learn how to create our own operators.